none of it's in English either. It's all in Swahili. It's like
All right.
The first 3 songs, mostly Swahili.
Okay. This first one right here, I want you guys, it's nothing new. I want you to work that one out for me. Okay? And I'm going to freeze my screen, and I'm going to work this one out up here as well. Together, because they are almost the same problem. Almost. But what is the difference in example 2? You got that X out there. So this becomes an issue because pretty much the only option you have for your U is to say that U is 2x minus 1, which means du is going to be 2x, or 2dx. Which you can still, just like we did on the last problem, you can put the 2 right there with the dx as long as you put a 1/2 out front. But here is the problem that we run into. This is u. This part right here is du. So if I write down what I've substituted in here, I've got 1/2 integral. Did I replace my x with anything? I did not. I've got the x still there. Then I've got the square root of u du. I cannot integrate this because I still have an x, right? Everything has to be changed to u's before you can integrate. So this is that x right there is a problem. Does anybody have any idea what we might could do with the x? You cannot, because you could not use the same letter because we have already defined u as 2x minus 1. So we would have to use a different letter. So we'd have to use like a v or a z or something. And then we'd still have 2 variables, so we wouldn't be able to do it. You cannot because it is a variable. If it was a coefficient, that would be fine. If we got like a 5 that's in our way, you can move it to the outside. Oh, wow, I'm so impressed because I think that's very hard to see. Yes, that is exactly what we're going to do. So u equals 2x minus 1. And we are going to add 1 to both sides. So u plus 1 equals 2x. And then we are going to divide by 2. So u plus 1 divided by 2 equals x. So this can be plugged in for our x, and then everything will be in terms of u. So these are the hardest ones that you're going to do of these type of problems. You're not going to see a ton of them, but you will see some of them. So you're going to have 1/2 integral of u plus 1 over 2 times, I'm going to write this as a u to the 1/2 think it'll make our lives a little easier if I do. du. Okay, we okay here? All right, so we still don't know how to integrate that because we got two things that are multiplied together. But what we can do is we can put this over 1, and we could distribute that u to the 1/2. So we will have 1/2 integral of, that'll be u to the 3/2 because we'll add our exponents. We got a 1 right here plus 1/2 will give us 3/2 plus u to the 1/2 all over 2 du. And then to make life a little bit easier, I would take this 2 because it could be like a coefficient like 1/2 times this stuff. I'd take it out here on the outside and I would write it as 1/4 u to the 3/2 plus u to the 1/2 du. Okay, most of the time for these, you're going to end up with more than one u, but you should be able to simplify it down to where it's just like still a power rule type of problem for that. So at this point, we're ready to take our integral. Make sure when you keep your 1/4 out here that you keep it in like parentheses. It's not been as important for the other problems because we only had a single u. But it needs to be separated out because it gets distributed to both terms that we get here. So we're going to get u to the 5/2, and we increase that exponent by 1, and then we will divide out front by 5/2, which will just flip that fraction, so we'll get 2/5. And then we'll get u to the 3/2, and we'll have 2/3 there, and we'll put a plus c out here on the end. You can put the plus c on the inside or the outside of that bracket. It really doesn't matter. If you put it on the inside, the 1/4 gets distributed to it. But c is an unknown term, so 1/4 of an unknown term is still just an unknown term. You can just leave it as c. So I just usually keep it at the end there. And then the last thing you have to do for this is you have to plug your u back in. So you'll have 1/4, 2/5, 2x minus 1 to the 5/2 plus 2/3, 2x minus 1 to the 3/2 plus c. There's several things they could do with that answer. They could distribute the 1/4 so that it would go to both terms. Or they might do sort of the opposite and like factor something out. That's a possibility. They could change it back to roots. We'll just leave it like it is here. Okay, questions? I think I'm not going to do this next example. I meant to take it off. Yeah, we're not going to do this one because it's not like really in this section. We already have known how to do that. Let's do example 4, which I already skipped. No, I had 2 there. So we can call it example 3. We'll call it 3 since we skipped that one. Okay, so for this problem, what do you guys think we should use for the u? 3x plus 2. It's kind of the only option right here. So u is going to be 3x plus 2, and du is going to be 3 dx. So like we've done on a lot of these problems, that dx needs a 3 with it, which means we got to put a 1/3 out front. And so this part right here is my u. This part right here is my du. But just like that last problem that we did, I've got this x right here. And it has to be replaced because I can't have any other variables besides u or I won't be able to integrate. So we're going to do like we did on the last problem. We're going to take our u equals 3x plus 2 and we'll solve that equation for x so that we can replace that x there. So we're going to subtract 2. So u minus 2 equals 3x. Then we'll divide by 3. And so we get u minus 2 divided by 3 equals x. So all of this stuff right here is u minus 2 divided by 3. Questions? Alright, now this is going to make kind of a mess whenever we do this. We got 1/3. In the numerator, we got u minus 2 divided by 3. In the denominator, we've got the square root of u. And then we've got our du over here. So we definitely cannot integrate it looking like this. We need to integrate. The only really way we know how to integrate is if we've got just a straight power rule. So we have got to do something to this to make it turn into a power rule problem. What do you guys want to try? What do you think? Okay, so I can put this over 1 like that and flip the second and multiply. I like that. This is not the only way to deal with it, but it's definitely a good way to deal with it. It's what I was thinking as well. Okay, and then if we want to combine those, we'd have u minus 2 over 3. I'm going to write this as u to the 1/2. We're probably going to have to go to fractional exponents eventually at least. Okay. All right, ideas now. Okay, so this 3 right here, I can just pull it out here to the front, which will make us have a 1/3 times 1/3 there, give us 1/9. That's a good idea. Okay, so I'll have 1/9, and then I'm taking this u to the 1/2. When I move it to the top, it has a negative exponent, and then I've got this u minus 2 needs to be in parentheses. Okay, let's distribute here. So you're adding your exponents whenever you do this here. So that's going to be u to the positive 1/2 minus 2u to the negative 1/2. Notice that I put parentheses around that. That's because the du needs to go with everything. So you need parentheses there technically to be correct with that du. It doesn't just go with the last term, it goes with the whole thing. Okay, let me give you a second there. What questions do we have? Okay, so then we're going to integrate using that power rule. So we're going to, the 1/9 stays out front. Make sure you got a bracket for it because there's 2 terms here. So you got u to the 3/2. You got to divide by the 3/2, which will give you 2/3 right here. And then for the second term, you're going to have u to the 1/2. And 2 divided by 1/2, dividing fractions is easy as pie. Flip the second and multiply, and you got a 4 right there. And our last step would be to plug the u back in. So we would have 1/9 times 2/3 3x plus 2 to the 3/2 minus 4 times 3x plus 2 to the 1/2 plus c. Let me look at the answers on the ones you have for homework and see if I need to do one more step here. Okay, I'm going to do this. So it's definitely, it is definitely okay on FRQ to stop here. I'm going to do this next part only because your textbook, I think, does this on a couple of the answers. And I do not know, they don't do it on all the answers, so I don't know why they do it on some and not others. But you may see this where they factor out a 3x plus 2 in this case. So let me simplify that way once at least so you have seen it. So I would probably go ahead and distribute that 1/9 just to have that not hanging out there up front. So I've got 2/27 times 3x plus 2 to the 3/2 minus 4/9 times 3x plus 2 to the 1/2. So we did this some when we were simplifying derivatives. Here, the 3x plus 2, you can factor out the term that has the lowest exponent. So where these two match, we can factor out the term with the lowest exponent. So that would be 3x plus 2 to the 1/2 power. So if we do that, we would have 2/27 times 3x plus 2 to the first power. Because it's like you're dividing right there. You're dividing by 3x plus 2 to the 1/2 power. And you would subtract those exponents, which would just give you 1. And then over here, you're going to be dividing by 3x plus 2 to the 1/2 power, which just cancels out. So you'd have minus 4/9 there. Some of the ones on your, in the textbook, they do that for the answer. So I would say try to match what the answer in the book is for those, because that is very good practice for multiple choice. It would depend on whether or not this was free response or multiple choice. If it's free response, definitely stop here and don't even try to go further. If it is multiple choice, you might have to if they've done it for the answer choices. Here we could distribute and we would get 3x plus 2 to the 1/2. We would have, this is going to be 6/27, but that would reduce to 2/9. So 2/9 x plus 4/27 minus 4/9. And that 4/9, I'm going to go ahead and make it 12/27 so I can combine those right there. So I might even write this as a square root, 3x plus 2. And then we've got 2/9 x minus 8/27 there. Oh, yeah, you should. Yes, I've lost it. All of these down through here should have a plus C. There's a chance they're not even going to like those fractions right there. Like they might pull out a 1/27, which would be like multiplying both of these by 27, which here would just cancel. And then that would be a 3, and we cancel with that 9. So that would be 6x minus 8 plus c. They could really take a 2 out, make that 2/27. Oh gosh, this one's awful. Because watch this, that's going to be, no, it won't go further than that. That'll be 3x minus 4 plus c. They could possibly go that far. So some of these, we do have plenty of time to work on this in class today because this is our last example. We're not doing much with that. So, I do want you checking the back of the book and trying to get your answer to match what they've got in the back of the book. Because sometimes that is the hardest part. And if these problems show up as multiple choice problems, you could run into having to do that. Now, if they're a free response, definitely don't try to do this. If they are a free response, stop right here where I said FRQ and don't do anything else because you might mess it up. But you might need to do this on some problems. So your assignment is going to be, let's see, to make sure I got this right, let me go to Canvas. Oh wait, what am I doing?
Are you counting on it, or are you just going to make sure everybody else is going to do it?
I'm just curious. Oh, yeah. It's not
All right.
I think you're going to have to then. The hyenas, oh my gosh, the hyenas are in the next
All right.
song that we get.
Dude,
Brady's big song.
I can't wait to see.
You have to be there for Brady's big song.
Okay, so the assignment is going to be 64 through 70, but number 69 is a very difficult problem, and I had to go find the answer, not just the answer key. I had to go find the, like, our old textbook had a answer guide with it that had them worked out. And I still had trouble, but I did eventually get the right answer. So this one, number 69 will be extra credit. So if you do that problem, then I will give you a late work or a bathroom pass for it. But it has to be right, and it has to have the correct work with it, because that is an odd problem. The answer is in the back of the book. So it has to be correct, and it has to have the correct work that goes with it. So, it is very tricky. There. The others, I'm not going to say they're easy, but they're like what we were doing in the work here. So, Emma, we have got time for you to do your FRQ.